Hello and welcome to another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 7, Lesson 2 on more properties of exponents. Now in the last lesson, the first one of this unit on exponents, we talked about, just basically what exponents were, how to think about them, and we saw one of the fundamental properties of exponents. Let's review that right away in the first exercise. All right, now recall that when we multiply two expressions that have the same base, that's the number or the variable that's being raised to the exponent, that their exponents add together, all right? Very, very simple rule, all right? Let's apply it in exercise number 1. Rewrite each of the following in simplest form. There is no need to evaluate. All right, why don't you go ahead and do so? All right, let's do it. So in the first one, we have 10 to the 5th times 10 to the 2nd, right? Very, very simple. All right, 10 to the 5th times 10 to the 2nd, right? I've got 5 10s multiplying each other, 2 10s multiplying each other. So at the end of the day, this means I've got 7 10s that are multiplying each other. That's it, right? Think about just if we just wrote them all out. I'd have 5 10s here, 10 times 10 times 10 times 10 times 10, 2 of them here times 10 times 10, right? So ultimately, I've got 7 10s that are multiplying each other. Now, we use this property a lot more with variables being raised to exponents than we do with just normal numbers being raised to exponents. So in letter B, we've got x to the 5th times x to the 3rd, and that's going to be x to the 8th, right? And in letter C, maybe a little bit trickier, right? We can always think of that y as being y to the 1st. So I have y to the 1st times y to the 4th gives me y to the 5th. A fantastic property of exponents that always holds. It doesn't matter what the base is. It doesn't matter what the exponents are. When we multiply the two together, right, as long as they've got the same base, then it just is that base raised to an exponent that is the sum of those two exponents. Now, let's explore some additional properties of exponents. All right, there are many, many additional properties of exponents. There are probably something on the order of 8 different exponent properties, all right? And by the time you're done with Algebra 2, which is a long ways away, you're gonna know every single one of them. All right, now each one of the exponent properties we can really make sense of by looking at examples. So let's take a look at exercise number 2. Consider the following two expressions, x times y, all to the 3rd power, and x divided by y, all to the 3rd power. Letter A asks us to write out each of these in their expanded form. All right, great. So we did this in the last lesson. I'd like you to write out each one of these in their expanded form, meaning write out the product that each one of these exponential expressions indicates. Pause the video now. All right, well, this first one is just x times y times x times y times x times y. And the second one is x divided by y times x divided by y times x divided by y. All right, simple enough. Now, letter B, simplify the expressions from A. All right, well, honestly, probably the first one is trickier to think about than the second one. But here's the thing you never want to forget about multiplication, right? Multiplication can be rearranged in any order you want, as long as it's all multiplication. So in the first one, this is literally x times y times x times y times x times y. I might not have the little dots between these x's and y's, but this means multiplying x and y together. So I could really rearrange this into x times x times x times y times y times y, and that's just x to the 3rd times y to the 3rd. Right? Now, when we've got fractions like this, that's even easier, because when we multiply 3 fractions together, we simply multiply all of their numerators and we multiply all their denominators. So x divided by y to the 3rd is x divided by y times, is really x times x divided by y times, come on, y, and that's x to the third divided by y to the third. Okay, so let's take a look at our exponent properties. Letter C. Fill in the following general properties. A times b raised to the n equals what? And a divided by b raised to the n equals what? Now, I want to be very clear. I've got a product raised to a power and a quotient raised to a power. I don't have a sum or a difference, right? I don't have addition or subtraction, and that's totally different. But when I have a times b raised to a power, that is simply a raised to the power times b raised to the power, right? That is exactly what we saw here. X times y to the third is simply x to the third times y to the third. And likewise, if I've got a quotient or a division raised to a power, then that is simply the numerator raised to the power divided by the denominator raised to the power. Again, in our one example, we've got x divided by y to the third, and that ends up being x to the third divided by y to the third. Okay? Again, I can't emphasize enough. If I had something like this, x plus y, let's say, to the third, this would not equal x to the third plus y to the third. I could not apply that power to both parts of that sum. It's not the way that it works. It'd be kind of awesome if that's the way that it works, but it's not. You'll work with more of this in Algebra 1. For now, as long as I have a product raised to a power or a quotient raised to a power, both parts of the product and both parts of the quotient are raised to that exponent. And those are really, I guess, exponent properties 2 and 3. You don't have to number them. They're not coming in any particular order. All right, let's take a look at exercise number 3. For each of the following, write in simplest form. Use the exponentiation button on your calculator to help evaluate numeric expressions. All right, so, have your calculator handy. They're particularly handy when we have to like cube or raise things to the fourth power or something like that. But let's do a simple one without our calculators. So here, I've got 5x, the product of 5 and x, raised to the second power. Our exponent property tells us then that that must be 5 to the second times x to the second. Now, there's absolutely nothing we can particularly do with the x to the second, but the 5 to the second, well, that's 5 squared, which is 25, and that's going to be 25x squared. All right? So what I'd like you to do now is pause the video and try to figure out the simplified versions of these two, being particularly careful in letter C. All right, we'll eventually talk about why you want to be particularly careful in letter C, but in letter B, right, I've got 12y to the third. That means I've got 12 to the third, y to the third. Now, 12 to the third is where we might want our calculators, and this is as good of a time as any to discuss where the exponent button is on your calculator. Now, it's going to depend upon the calculator that you have, all right? But generally speaking, there should be a button on your calculator that looks something like this. The technical name for that button is the caret button. I don't know why. It doesn't look like a carrot to me. It's even spelled different than the word carrot, but that's what it's called, the caret button. And this literally means raise this number to this power. So if I want 12 to the third, what I'm going to do is I'm going to do 12, the caret button, and the 3, right? And that's going to give me 1,728. So 1,728 y to the third. Ah, nice. Okay. And finally, letter C. Now notice in these cases, I took that number and I just wrote it with the power sitting there. But here I've got a negative. And in that case, it's really kind of critical that you write this down. All right, -2 in parentheses raised to the fifth. All right, then, oops, that's not right. Then times n raised to the fifth, okay? And then when I'm trying to figure out what that -2 to the fifth is, I'm going to use parentheses on my calculator. I'm going to put -2 in, I'm going to raise it to the fifth, and I'm going to get -32. Now you might say to yourself, wow, I got that anyway, and I didn't put it in parentheses. That was because we had a negative raised to an odd power. On the other hand, if you had had, let's say, negative 2n to the fourth, any negative raised to an even power really should give you a positive. Remember, a negative times a negative is a positive, so if you have an even number of them, then you should get a positive. And just as a little aside, if I had negative 2 and I put it into the fourth power without parentheses, it gives me negative 16, but it really shouldn't, right? It really shouldn't, right? Negative 2 times negative 2 times negative 2 times negative 2 should be positive 16 because that sign should turn out as positive. That's why it's so critical to have the negative in parentheses. And then it will always give you the right answer. You can never go wrong with that. You know, you could put every single one of the numbers, whether it's a fraction, a positive, a negative in parentheses, and then there's no worries. All right. Anyhow, we'll keep seeing that issue as we go on and on and on. Let's keep going. All right. Now we have one further exponent property that we're going to explore in this lesson, and then we'll start looking at one other exponent property in the next lesson. The particular exponent property we're going to look at right now is the exponent property that applies when you have something raised to an exponent that then is raised to another exponent. So if I had something like x to the fifth raised to the third, right? So this is this exponent property. What happens when I have something raised to an exponent, then raised to another exponent? What rule applies? Well, again, let's take a look at this with some examples. And first, let me get rid of that. All right, let's take a look at exercise number 4. Consider the expression x squared to the fourth and y to the fifth to the third. All right. Letter A, fill in the blanks below, and letter B, fill in the blanks below. Let's do letter A together. Okay, here we've got x to the second to the fourth. Well, again, I don't really care what's in that parentheses. If I have something raised to the fourth power, that means that thing, no matter what that thing is, should multiply itself 4 times. So let me write this a bit bigger. I have x to the second to the fourth. Right? So that should be x to the second times x to the second times x to the second times x to the second. But now, my exponent property that says add the exponents together kicks in. So I have x to the 2 plus 2 plus 2 plus 2, right? Which is the same as x to the 4 times 2, which is x to the 8th. Right? And it's pretty simple. As long as you know what exponents tell you, and you know the property that says to add the exponents, then you can see that x to the second raised to the fourth is x to the 8th. Why don't you do exactly the same thing for this problem where we have y to the fifth, then raised to the third? Pause the video now. All right. Again, let me write this a little bit bigger. We have y to the fifth being raised to the third, so that must be y to the fifth times y to the fifth times y to the fifth. But now our exponent addition property kicks in, so that's y to the fifth plus 5, or y to the 3 times 5, which must be y to the 15th. All right. So, what is the general exponent property? Let's take a look at that in letter C. Can you generalize the pattern that you see in A and B? Fill in the exponent property. I have x to the A raised to the B. What should that equal? Pause the video now. Well, that is simply x to the A times B, right? Right? When I have something raised to an exponent, then raised to another exponent, I multiply the two exponents, right? X to the second to the fourth is x to the 8th. 2 times 4 is 8. X to the fifth to the third is x to the 3 times 5, or sorry, y to the 3 times 5, which is y to the 15th. So anytime I have something raised to an exponent, which is then raised to another exponent, I multiply the two exponents. Let's apply that in letter D. Use your pattern in C to simplify y to the fourth to the 11th, right? So here's a situation where I wouldn't want to write out y to the 4th times 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 y to the... I wouldn't want to do that 11 times. But this exponent property allows me to not have to do that. What would I get? Pause the video now. Well, it's really simple. I'll get y to the 4 times 11 or y to the 44th. Okay. And again, this flows beautifully from two things. One, what do exponents just mean in the first place? And two, the addition property of exponents, right? Okay. Now, obviously, right, we often have to use multiple exponent properties in order to write an expression in simplest form. So let's take a look at a bunch of those in exercise number 5. Let me bring it up to the top of the page. Let's take a look. Write each of the following expressions in simplest form by applying the properties of exponents seen in this lesson. Write out the steps of your manipulations. Okay, great. So let's take a look at letter A. Right? Again, I'm gonna write this a bit bigger. I've got 5x to the 4th squared. Okay, so I've got two things here, two properties I have to use. One, I have a product going on inside of here, 5 times x to the 4th. Now, we saw that exponent rule that says if I have a product raised to an exponent, that exponent, if you will, gets applied to both parts of the product. So I'm going to have to raise 5 to the 2nd power, right? And I'm going to have to raise x to the 4th to the 2nd power. Now 5 to the 2nd power, that's simple. That's 5 times 5, or 25. And then when I have x to the 4th raised to the 2nd, I'm going to multiply those two powers now and get x to the 8th. All right, I'm not going to add the two powers, right? I only add powers when I'm multiplying two things that have the same base. In this case, I've got something raised to an exponent raised to another exponent, and the rule that kicks in there is that I multiply the two exponents. Let's do another one of these together just to make sure you have the right idea. In letter B, I've got 10 y to the 2nd all to the 3rd. Very, very similar in structure to letter A. I've got a product inside of here all being raised to the 3rd. That means that I want to take the 10 and raise it to the 3rd, and I want to take the y squared and raise it to the 3rd. Now 10 to the 3rd is one that I'm not breaking my calculator out for. I might do that on some of the other ones, but 10 to the 3rd should be easy enough. That's 1,000, right? And y squared to the 3rd, again, we have that property, something raised to an exponent raised to another exponent. I multiply the two exponents, and I get 1,000 y to the 6th. All right, what I'd like you to do now is I'd like you to work on the remaining 4 and see what you get. Pause the video now and try to simplify each one of these expressions. All right, well, let's take a look at letter C. I've got, again, writing it out, negative 2n to the 5th all to the 3rd, right? So that's going to give me negative 2 to the 3rd times n to the 5th to the 3rd. I would encourage you, anytime you have small numbers raised to small exponents, to try to do them in your head. So negative 2 to the 3rd is negative 2 times negative 2, which is positive 4, times negative 2, which is negative 8, right? So that's going to be negative 8, and then I'll have n to the 15th. All right. Let's take a look at some quotients. Now with quotients, they work just like products. In other words, each part of the quotient, the top and the bottom of the fraction, should have that exponent applied to them. So when I have x to the 5th divided by 9 squared, that should be x to the 5th squared divided by 9 squared. All right. Now, x to the 5th squared, we pop into that exponent property that says multiply the two exponents. And of course, 9 times 9 is 81. So x to the 10th divided by 81. Let's take a look at letter C, right? This one is an interesting one. Again, let me write it a little bit bigger for you. I have 1 divided by x to the 8th, all raised to the 5th. And again, just like this problem, I'm going to apply that fifth exponent to both the numerator and the denominator, which is going to give me 1 to the fifth in the numerator and x to the eighth to the fifth in the denominator. Now, I like this problem because it illustrates a very important property of any exponential expression where 1 is the base. Now, if you think about it, 1 times 1 is 1, times 1 is 1, times 1 is 1, times 1 is 1, right? And what am I getting at here? 1 raised to any power whatsoever is equal to 1. 1 raised to any power is equal to 1, because no matter how many times you multiply 1 by itself, you get the number 1. So 1 to the fifth is equal to 1, and x to the eighth to the fifth is x to the 40th. All right. And finally, a combination of a bunch of different rules, right? Now we have a fraction, right, where the numerator has a product in it, right? So the numerator has to be raised to that power. The denominator has to be raised to that power. Let me write all of this out kind of in its kind of glory. So I'll have 2x squared to the third divided by 5 to the third. But that means I have 2 to the third times x squared to the third, all divided by 5 to the third. Now I'm going to run out of room, right? 2 to the third is 2 times 2 times 2, that's 8. X squared to the third is going to be x to the sixth, and 5 times 5 is 25, times another 5 is 125. So 8x to the sixth divided by 125. Try to do as many of the exponents that involve normal numbers as you can without a calculator. It's important because as you move on in math, more and more you're going to be expected to just know, oh, 2 to the fifth is 32, 3 to the third is 27, 4 to the third is 64, right? They're not going to want you to be grabbing that calculator to try to figure it out. And in fact, it's important that you know some of those basics. If I get 13 to the fifth, I'm doing that on my calculator. Do you know what I mean? Or even if I got something like, 125 to the second, I'm not doing that by hand. We're talking about single-digit numbers raised to small-ish exponents, 2, 3, 4 kind of stuff. No more than that. All right, let's wrap this up. So today, we actually saw 3 additional exponent properties, right? One was that if I had a product raised to an exponent, both parts of the product get raised to the same exponent. If I have a quotient, i.e. a fraction, raised to an exponent, both the numerator and denominator get raised to that exponent. And we also saw, and this is a tricky one, when I have something raised to an exponent that's then raised to an additional exponent, those exponents multiply each other. All right, we're going to need all these exponent properties as we work through this unit on exponents, so make sure to get really good practice on the homework. For now, I just want to thank you for joining me for another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.